Hello everyone, my name is Magali Solomon and now I'll be presenting my potato catalase enzyme experiment. So here's the purpose of this experiment. With this experiment, we hope to find the rate of reaction in boiled potato versus a non-boiled potato when placed in hydrogen peroxide. After, we will compare the reaction rates between sweet potatoes and Yukon Gold potatoes. Here are the materials we will need for this experiment. What we'll need is a pot, 2 bottles of hydrogen peroxide, a measuring cup, 1/2 a cup, to make sure that both of the potatoes will be placed in exactly 1/2 a cup of hydrogen peroxide, 2 glasses, which we will use to place the potatoes in, 4 bottles of 16.9 fluid ounces bottles of water, a knife to cut our potatoes, and a Yukon Gold potato and a sweet potato. So here's the scientific reasoning / expected results. So this chemical reaction should take the hydrogen peroxide, which will react with the catalase, which is an enzyme found in the potato, which will convert to water and oxygen. So because of this reasoning, I expect for the Yukon Gold potato to react faster because it contains more amounts of catalase in it, which, as I said before, will turn hydrogen into water and oxygen, while sweet potato doesn't really contain that. Instead, it contains amylase, which aids in catalyzing the hydrolysis of starch into sugars. So as you can see, this little reaction shows you how hydrogen peroxide, after it reacts with the catalase in the Yukon Gold potato, it later turns into water and oxygen. So here are the steps. So step 1, we want to make sure that we're cutting our sweet potato and Yukon Gold potato in half, okay? As the picture shows. Our second step is going to be boiling 1/2 of the sweet potato and 1/2 of the Yukon Gold potato. So after cutting the potatoes in half, I put 4 bottles of water to boil. And now the next step is simply placing the potatoes in so that they can boil. We will place the non-boiled potatoes in 2 separate glasses of 1/2 cup of hydrogen peroxide and now compare their reaction rate. This one appears to be having a faster reaction rate as opposed to the sweet potato. Next, we will place the boiled potatoes in 2 separate glasses of 1/2 a cup of hydrogen peroxide and, of course, compare the reaction rate. As you can see with the bubbled potato, there is much less of a reaction for both the sweet potato and the Yukon Gold regular white potato. So here's a little recap of the reactions we just saw. So here are the reactions to the non-boiled Yukon Gold potato and the sweet potato. So as you can see, this image on the left shows us basically a top view, and as we can see, there is a lot of bubbling and more active um, enzyme reactions going on, of course, with the Yukon Gold potato, as I predicted, and that's basically because the Yukon Gold potato has the catalase enzyme, which, as we said, would of course result in more of an reaction as opposed to the sweet potato, which has amylase, which just basically aids with turning the hydrolysis into complex sugars. So why so many bubbles? So as we kind of explained before, the enzyme catalase went to the surface of the potato and it is breaking down the hydrogen peroxide into water and oxygen. So when this oxygen gas is released, these bubbles are formed. And now we're going to see how adding heat kind of hindered the reaction. So again, here are the reactions to the boiled Yukon Gold potato and the boiled sweet potato. So as you can see from this top view, if you couldn't already tell in the previous video, uh, there was basically no reaction present, and it's because of the added heat. So with all that being said, when comparing all of our data, we can safely come to the conclusion that non-boiled Yukon Gold potato obviously takes the win with having the faster and larger reaction, of course, because as we suspected before, it has more amounts of catalase than the sweet potato. So the reason why boiling the potato did not speed up this reaction, which I feel like is more of a common misconception people have, because usually we're taught that adding heat really is supposed to speed up every reaction, but in this case, the increase in temperature denatured the enzyme, which in this case made it virtually unuseful, and it also, um, from a smaller, more microscopic, I guess you can say, view, changed the shape of the enzyme itself. So that is the end of the presentation. Thank you so much for listening.